In this video, we are solving trigonometric inequalities. This is AP Precalculus topic 3.10. If you appreciate the content, please give it a like. Number 1. What are all values of theta on the interval from 0 to 2 pi for which sine theta is greater than or equal to radical 3 over 2? If you have not yet memorized these 9 trig facts, pause the video and memorize this chart right now. We can find the reference angle by asking ourselves the sine of what angle is equal to radical 3 over 2. We have memorized that the sine of pi over 3 is radical 3 over 2. So the reference angle is pi over 3. The reference angle is the angle between the terminal side and the x-axis. On the interval from 0 to 2 pi, here are the 4 angles with a reference angle of pi over 3. Since we want the sine to equal positive radical 3 over 2, we will stick to the first quadrant and the second quadrant, where the y value, and thus the sine function, is positive. We can think of pi as 3 pi over 3. So this angle in the second quadrant is 2 pi over 3. Of course, the angle in the first quadrant with a reference angle of pi over 3 is pi over 3 itself. Sine is the y value, or vertical displacement, on the unit circle. We are looking for where the y value is greater than or equal to radical 3 over 2. I've drawn this blue horizontal line to represent a y value of exactly radical 3 over 2. Always begin rotating from the positive x-axis. We are looking for where the y value of this endpoint is greater than or equal to radical 3 over 2. Well, it is equal to radical 3 over 2 right here. And as I continue to rotate during this interval, the y value, the vertical displacement, is greater than radical 3 over 2. See how it's above the blue line? And then it starts to fall again, and it hits exactly radical 3 over 2 right here. If I continue to rotate beyond this angle, the vertical displacement, the y value, is now going to be below radical 3 over 2, all the way continuing on to the end of the interval. We just saw that the values of theta, where the vertical displacement is greater than or equal to radical 3 over 2, were from here to here. So we can write the solution set in interval notation by going from pi over 3 to 2 pi over 3. We will use brackets to indicate that these endpoints are themselves solutions and should be included. That's because we wanted where the y values are greater than or equal to radical 3 over 2. And right at pi over 3 and 2 pi over 3, this is where the vertical displacement is exactly equal to radical 3 over 2. This is interval notation. You can also write your answer as an inequality like this. Pi over 3 is less than or equal to theta, which is less than or equal to 2 pi over 3. Both versions are acceptable on a free response question. Either might appear on a multiple choice question, so be familiar with both formats. Number 2. What are all values of theta on the interval from 0 to 2 pi for which the cosine of theta is less than 1/2? We can find the reference angle by thinking the cosine of what angle is equal to 1/2. We have memorized that the cosine of pi over 3 is 1/2, so pi over 3 is the reference angle. On the interval from 0 to 2 pi, here are the 4 angles with a reference angle of pi over 3. Since we want cosine to equal positive 1/2, we will stick to quadrants 1 and 4, where the x value and thus the cosine will be positive. The angle in the first quadrant with a reference angle of pi over 3 is pi over 3 itself. We can think of 2 pi as 6 pi over 3. Therefore, this angle in the fourth quadrant is 5 pi over 3. Remembering that cosine is the x value on the unit circle, the horizontal displacement, we will now look for the angles where the horizontal displacement is less than 1/2. The fact that the cosine of pi over 3 is exactly 1/2 means that the horizontal displacement at pi over 3 is 1/2, represented by this vertical blue line. We're looking for where the horizontal displacement is less than 1/2, but we always have to start rotating from the positive x-axis. This is 0 radians. So as we begin our rotation, notice that we are to the right of the blue line. The horizontal displacement is greater than 1/2 until we get to pi over 3. Right here, the horizontal displacement is equal to 1/2. As we pass this angle, as we go past pi over 3, the horizontal displacement is now less than 1/2. We are to the left of the blue line. That will continue to be the case all the way around until we get back to 5 pi over 3. So we have just found the interval of the solutions. The angles where the horizontal displacement is less than 1/2 will be all of the angles between pi over 3 and 5 pi over 3. After I pass 5 pi over 3, the horizontal displacement is once again greater than 1/2, to the right of 1/2. Using interval notation, we saw that the solutions are between pi over 3 and 5 pi over 3. So we simply write pi over 3, comma, 5 pi over 3. But will we use brackets or parentheses? In this case, we will use parentheses on these endpoints because we are looking for where the x value is less than 1/2. Right at pi over 3 and right at 5 pi over 3, the horizontal displacement is equal to 1/2, not less than. So we don't want to include the endpoints, and we show that by using parentheses. Of course, you can write your answer using an inequality by writing pi over 3 is less than theta, which is less than 5 pi over 3. Either is acceptable on a free response question. Be familiar with both for a multiple choice question. Number 3, let f of x equal sine x. What are all values of x in the xy plane between 0 and 2 pi for which f of x is greater than or equal to negative radical 2 over 2? So, in other words, where is sine x greater than or equal to negative radical 2 over 2? We need to start by thinking about where sine x is equal to negative radical 2 over 2. We can find the reference angle by ignoring the negative sign and asking the sine of what angle is radical 2 over 2. We have memorized that the sine of pi over 4 is radical 2 over 2, so pi over 4 is the reference angle. On the interval from 0 to 2 pi, here are the 4 angles with a reference angle of pi over 4. Since we want sine to equal negative radical 2 over 2, we will stick to quadrants 3 and 4, where the y value, and thus the sine function, is negative. We can think of pi as 4 pi over 4, so this angle in the third quadrant is 5 pi over 4. We can think of 2 pi as 8 pi over 4, so this angle in the fourth quadrant is 7 pi over 4. Sine is the y value on the unit circle. It is the vertical displacement. This blue line represents a vertical displacement of negative radical 2 over 2. We are looking for where the vertical displacement is greater than negative radical 2 over 2. In other words, where is the y value above this blue line? We always start at 0 radians, and then we sort of rotate from there. So notice that right here at 0 radians, the vertical displacement is above the blue line. So this is a solution immediately. As we begin to rotate around, all right, focus on the endpoint. The y value is still above negative radical 2 over 2. And that will continue to be the case all the way until I get to this position. So this is where the vertical displacement is exactly negative radical 2 over 2. We are on the blue line now. So we have found the first interval where the solutions exist. The first interval is going to be between 0 and 5 pi over 4. Here's the first set of solutions in interval notation. Remember that we use brackets to show that these endpoints are included. At 0, the y value is greater than negative radical 2 over 2. So 0 should be included in the solution set with a bracket. At 5 pi over 4, the vertical displacement equals negative radical 2 over 2. And we are looking for where sine x is greater than or equal to negative radical 2 over 2. So 5 pi over 4 should be included with a bracket. So far we have found that the vertical displacement is above negative radical 2 over 2 from 0 to 5 pi over 4. As we pass 5 pi over 4, notice that the y value, the endpoint here, is now below negative radical 2 over 2. We're below the blue line. That will continue to be the case until we get to 7 pi over 4. So we will have no solutions between 5 pi over 4 and 7 pi over 4. At 7 pi over 4, the vertical displacement is exactly negative radical 2 over 2 again. So this will be the beginning of a new set of solutions. As we rotate past 7 pi over 4, the vertical displacement, that y value, is again above negative radical 2 over 2, all the way until we get back to this position, which now we will call 2 pi. So the second set of solutions will be between 7 pi over 4 and 2 pi. Notice that we will include both of these endpoints in the solution set because at 7 pi over 4, the vertical displacement is negative radical 2 over 2. So that's included in the or equal to. And at 8 pi over 4, well, at 2 pi, the vertical displacement is greater than negative radical 2 over 2. So that is a solution and should be included. So here's your final answer in interval notation. And here it is again as an inequality. Either is fine for a free response question. Be familiar with both for a multiple choice question. Number 4, let f of x equal 3 plus 4 sine x and let g of x equal 1. What are all values of x in the xy plane from 0 to 2 pi for which f of x is less than g of x? So that means we want 3 plus 4 sine x to be less than 1. Subtracting 3 from both sides, we get 4 sine x is less than negative 2. Dividing both sides by 4, we get sine x is less than, and negative 2 over 4 simplifies to negative 1/2. To find where sine x is less than negative 1/2, we start by thinking about where sine x is equal to negative 1/2. We can find the reference angle by ignoring the negative sign and asking the sine of what angle is 1/2. We have memorized that the sine of pi over 6 is 1/2, so pi over 6 is the reference angle. On the interval from 0 to 2 pi, here are the 4 angles with a reference angle of pi over 6. Since we are looking for where sine x is negative 1/2, we will stick to the third quadrant and the fourth quadrant, where the y value and thus the sine function is negative. We can think of pi as 6 pi over 6. So this angle in the third quadrant is 7 pi over 6. We can think of 2 pi as 12 pi over 6. So this angle in the fourth quadrant is 11 pi over 6. Sine is the y value on the unit circle, and the sine of 7 pi over 6 and 11 pi over 6 is negative 1/2. So this blue line represents a vertical displacement, or a y value, of -1/2. We are looking for where the y value is less than -1/2. That's below this blue line. As always, we need to start rotating from 0 radians, and we rotate this way. Notice that at 0 radians, the vertical displacement, or the y value, is above -1/2. It's above the blue line. So we have no solution here. As we rotate, we are still above -1/2, so we have no solutions, no solutions. We are looking for where the vertical displacement is below -1/2. When we finally rotate to 7 pi over 6, the vertical displacement of this endpoint is exactly -1/2. This will still not be a solution because we want the y value to be less than -1/2. So the solutions will begin right after 7 pi over 6, and on this interval the y value is below -1/2 until we get to 11 pi over 6, where the vertical displacement is back to -1/2. This will not be a solution because it's equal to -1/2, not less than. So once again, the solutions will be on this interval from 7 pi over 6 to 11 pi over 6, because this is where the y values are below -1/2. In interval notation, the answer looks like this. And as an inequality, the answer looks like this. Remember, we show that the endpoints themselves are not included as part of the solution set using parentheses in interval notation, and by using less than signs as opposed to less than or equal to signs. Number 5, let h of x equal 3 cosine x, and let k of x equal 1 plus 5 cosine x. What are all values of x in the xy plane between 0 and 2 pi, for which h of x is less than or equal to k of x? So we are looking for the values of x for which cosine x will be less than or equal to 1 plus 5 cosine x. Subtracting 5 cosine x from both sides, we will get -2 cosine x is less than or equal to 1. Dividing both sides by -2. Wait! Be careful. You have to remember back to Algebra 1 when you learned that when you divide or multiply by a negative number, you must always remember to reverse the direction of the inequality. So please be very careful and remember to do that. So dividing both sides by -2, we get cosine of x is greater than or equal to -1/2. First, we think about where cosine x is equal to -1/2. We can find the reference angle by asking ourselves the cosine of what angle is 1/2, ignoring the negative sign. We have memorized that the cosine of pi over 3 is 1/2, so pi over 3 is the reference angle. On the interval from 0 to 2 pi, here are the 4 angles with a reference angle of pi over 3. Since we are looking for where cosine is equal to -1/2, we will stick to the second quadrant and the third quadrant, where the x value and thus the cosine will be negative. We can think of pi as 3 pi over 3. So this angle in the second quadrant must be 2 pi over 3. And this angle in the third quadrant must be 4 pi over 3. Cosine is the horizontal displacement on the unit circle. So this blue line right here represents a horizontal displacement of -1/2. We are looking for where cosine x, the horizontal displacement, is greater than or equal to -1/2. So we are looking for the angles where the horizontal displacement is to the right of this blue line. We always start our rotation at 0 radians. Right here, the horizontal displacement, the endpoint of this orange segment, is to the right of the blue line. So this will be included in the solution set. So solutions start here at 0. We are still to the right of the blue line as we rotate. all the way until we get to 2 pi over 3. At 2 pi over 3, the horizontal displacement is negative 1/2, which will be included because we are looking for where cosine is greater than or equal to negative 1/2, so that includes this position. So we have just found our first interval of solutions from 0 to 2 pi over 3, including the endpoints. So far we have this. Remember to use brackets to show that the endpoints are included in interval notation, and we use less than or equal to show that the endpoints are included as an inequality. So let's pick up where we left off. So far we found that we have solutions on the interval from 0 to 2 pi over 3 because the horizontal displacement is greater than negative 1/2. We are to the right of this light blue line. As we pass 2 pi over 3, the endpoint is to the left of the blue line. The horizontal displacement is less than negative 1/2. This is not what we are looking for, so we will have no solutions in this interval between 2 pi over 3 and 4 pi over 3. However, at 4 pi over 3, we again have a solution, because at 4 pi over 3, the horizontal displacement is negative 1/2, which is one of the things we are looking for. So solutions will start at negative 1/2, and the endpoint continues to be to the right of the blue line. As we rotate in this direction, the horizontal displacement is greater than negative 1/2 all the way until I get to the end of the domain at 2 pi. 2 pi itself will be included as a solution because, of course, we are still to the right of the blue line. The horizontal displacement is greater than negative 1/2. Again, when we record the answer in just a moment, the solutions will be from 4 pi over 3 to 2 pi, including the endpoints where the horizontal displacement is equal to negative 1/2 and greater than negative 1/2. Here's your final answer written in interval notation and as an inequality. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.